Okay, so I assume you have read and worked over the problem. So let's go ahead and start. Okay, so the first part can be a little tricky. It says find the area of R. Okay, well, I'm going to kind of do this a different way. You don't have to do it the same way, but it's definitely easier. I'm going to look at that as that's a fourth of a circle. So I'm going to use geometry for that part and then find the harder part there using my integral. So right away I have that fourth of a circle. So 1/4 pi, my radius is 3 squared. Because, by the way, r equals 3, that's where I'm getting that. Okay, so that's part of that's this area right here. Then I want to have, don't forget your formula for polar, 1/2 area squared. So I went from now 0 to pi over 2, quarter of a circle again. And that's my other function, 3 minus 2 sine 2 theta squared d theta. Right, r squared, 1/2 integral of r squared. I end up getting approximately 9.708. And that was worth 3 points. So that's a nice 3-pointer. But much easier if you break it into 2. Okay, part B for the curve. So just that one curve. That weird one. Okay, this funky one here. Okay. Find the value of dx d theta when x is pi over 2. Now remember, we did these on the free response, we did polar. X is r cosine theta. So in our case, my r is 3 minus 2 sine 2 theta cosine theta. Okay, so that's x. Now when I take a derivative, this is calculator active, so remember you can use your derivative at a point. You're evaluating at pi over 6. You get approximately negative 2.366. And that is worth 2 points. Okay. Part C, find the distance between the two curves. Find the distance between the two curves changes at theta between 0 over 2 pi. Okay, so the distance, remember, just means subtract. So if I want the distance, this is part C, distance is just one curve minus the other. And we're in 0 to pi over 2, so that's why by order. So it's this one minus that one, this one minus that one. Okay, so make sure you have the 3 first. Okay, now it wants to know, find the rate at which this is changing, so that's just a derivative. So d dt, once again, we have a calculator. Theta is approximately, or theta is pi over 3. We end up getting negative 3. That was worth 2 points as well. Okay. Part D, particles moving along the curve, so that we have d theta dt is 3. Find the value of dr dt when theta is pi over 6. So this is where you have to get a little creative here, because we don't have a dr dt, but we do have a d theta dt. And we know that if I get a little creative, d theta dt, I want to do some operation, usually multiplication, and get dr dt. Okay, so that's what I want to get there. Or excuse me, yeah, we have said this all wrong. No, we're good. D theta dt, and I have dr dt, or dr d theta, is what's going to get rid of my d theta, right? Okay. So I'll end up with dr dt. But anyway, that's kind of where I'm get this from, is I said, okay, I have a d theta dt. It's what they give me here. That's 3. I need to multiply by something, kind of like you're getting rid of units in science class. You're converting. I wanted them to reduce to get dr dt. So now we know dr d theta, let's see, that is 3. I already put that on there. Dr d theta is negative 2. So I've got some different order here. Okay, so now I end up with dr dt is negative 6. 2 points there. 2 points.